Welcome to the Charging a Capacitor lab. Your desk should be free of any clutter as you connect your resistor, capacitor, switch, ammeter, connecting wires, voltmeter, and power supply together. Keep the bag with the extra resistor and a discharging wire nearby. To provide power for the lab, you'll need to connect some wires to the power supply. Here I've selected a red alligator wire to connect to the positive terminal of the DC output and a black alligator wire, but banana plugs would work just as well. To test and see if you have power, or in other words if you've established a potential difference between the free ends of the wire, touch them together and look for sparks. If no sparks appear, you have a couple choices. First, check the reset buttons on the power supply. Or more simply, turn up the dial to set the voltage. Now touching the wires together gives the desired effect. Connecting all the components together in a series loop can be challenging. Take the bag full of components, remove your capacitor, remove the switch, find the 470 ohm resistor, and the 1000 ohm resistor. Connect the positive terminal to the positive power supply wire and the negative terminal to one side of your switch. Then from the other side of the switch to the resistor. Now you've completed the loop. A digital multimeter can serve as a voltmeter. Set it to the 20 volt scale. Connect it to banana plugs and use those plugs to connect to the power supply. The voltmeter should read 10 if the dial is at the correct setting. A separate digital multimeter can be used as an ammeter in this circuit. Break the circuit open at the switch and connect to the negative terminal of the ammeter and the other side of the switch to the positive terminal of the ammeter. Dial it to the 200 milliamp scale. Disconnect the capacitor, reconnect it with a discharge wire, and now reconnect the capacitor and close the switch. At this point, you'll record the values of the current on the ammeter. You'll see that they slowly fade away. This is due to the time constant, or in other words, the value of tau established by the product of R and C. Open your switch, disconnect the capacitor, discharge it, and replace it with the other resistor. When you're all done, make sure you turn off the ammeter. To check and see if your loop is hooked up in a proper series connection, just follow the wires all the way around. You should see that every single element follows one after another. The exact order doesn't matter. In other words, the resistor can come before or after the capacitor. The voltmeter is connected on its own separate loop. We say that in this lab the voltmeter is connected in parallel in the circuit. To collect data, you need to close the switch and read the values on the ammeter. The ammeter comes with a hold function. This makes it easy to write down values in your data table. Each time you press the hold button, it freezes the number on the screen. Releasing the hold button allows the values to steadily fall once again. The current will slowly decay towards zero, and after about 2 minutes, you'll open the switch. At this point, you're done collecting data. Now that the switch is open, you'll want to discharge the capacitor before connecting a new resistor. Disconnect the leads and use the single wire to reconnect them. This provides a path for discharge among the two terminals of the capacitor. Well, that's the end of the video for the Charging a Capacitor lab. If you have any further questions, make sure to ask your teacher.